So the question is, how many states can a student name in 1 minute? So we ran an experiment in an AP Stats class as a random sample of all AP Stats students to estimate the 95% confidence interval for the mean number of states a student can name in 1 minute. All right, so here's the summary of the data right here. So there's 32 in the class. The average was 16.81. And the max was what? 32? Okay. Some of you guys know the state song. Those people can usually do it in less than a minute. So, but then those of us who don't know the state song, it's kind of sad. Anyway, so here's a dot plot of the data. You can see it. Here's the summary. What do we need? We need, from this, we need the mean, the x-bar, and we will need the standard deviation of the sample, all that together. All right, so let's just warm ourselves up with a little vocab here. Is this data categorical or quantitative? Quantitative. Quantitative. What did quantitative data mean? What does that mean? Numerical that you average, that you would average. Okay. All right. So then it says construct an interval to estimate. Now, anytime you see a question from here on out that says construct an interval, you're going to work through the whole 4-step process. It may not spell it out to you. It may not hold your hand, but that's the expectation, is that you do all 4 steps. So we're going to revisit those 4 steps. The nice thing is, you won't ever have more than 2 of these on any kind of test, because they are time consuming. But it means there's a lot of steps in there that you don't want to skip, right? So let's look at this. On the state step, it says state the parameter that we want to estimate and the confidence level. So in this case, honestly, in most cases, if you look at the problem stem, it will define the parameter for you. All you have to do is put the correct symbol. So mu equals the true mean, number of states a senior can name in 1 minute. That's what we're going with here. And we want to do it with 95% confidence. Okay? All right, plan step. First thing we need to do is identify the procedure. Like, what equation are we using? What's the process here? Well, before it was the 1 proportion z interval, right? But now we're switched to means, which means the name of it is the 1 sample t interval. Remember, we've changed to a t interval instead of the normal distribution? That's unique to means. Conditions, same 3 conditions we've done before. So first of all, we check, is the sample random? Yeah. Yep, it's stated it's random. And this is where I put my sample size, 32. My next condition is what, 10%? Independence. So I asked myself, is 32 less than 10% of all AP Stats students? Yes, there's thousands of AP Stats students. Hundreds of thousands. All right. And then normal. Friday, we revisited, there's different ways we can know a sample mean is going to be normal in its sampling distribution, if the population's normal, central limit theorem, or if we have to graph the sample data. Those are our 3 options. Which one of these works on this one? Well, we could. It did give us a graph, right? But do we need it? Our sample size is 32, so we don't have to bother with it. So go the easy way, right? So go with that. So we would say n is 32, which is greater than or equal to 30. So by the central limit theorem, we know it's approximately normal. Always contain that central limit theorem, CLT, in there. You don't have to spell it out, but give 30 some context, okay? And in the do step, this is where we're going to do the calculations. So the formula is going to be x bar plus or minus t star, and then we use our sample standard deviation over the square root of n. That's our standard error with means. Max, are you with us? Okay, then we plug in our values. It gave it to us in the table. So our x bar is 16.813. Let's leave a space for t star. We'll come back and do that. Standard deviation, the S of x is the 5.527 over the square root of my sample size. Now, let's revisit. What did we do the Friday? How did we find our t star? Do you remember? It's very similar to z star. If I put 0.95 in the center, what's in the tails? 0.02. All right, where do I go in my calculator?
Inverse t.
Good. Inverse t. It's going to ask me for area, which you just said is 0.025, and then df. Anybody remember what df stands for? Degrees of freedom. And how do we find it? N minus 1. It's just your sample size minus 1. Okay, so in this case it's 31. So let's see what we come up with here. I get 2.04. Okay, now I have what I need to calculate this guy. So I'm going to take 2.04 I'm going to call that 820. And 18.806. Okay. So remember, this is the range of plausible values for the true mean number of states a student can name in a minute. So then we have our last step of conclude. How do we start our conclusion? Yeah.
We are
95% confident that
95%.
no.
The mean number of states.
Okay, we can do that. The mean number of states a student can name in 1 minute is between 14.82 and 18.81 states. If you phrased yours differently, maybe you said we're 95% confident that the interval from 14.82 to 18.81 captures the true mean number of states a student can name in 1 minute. That's perfectly acceptable as well. Okay? So either one works. You do the one that you can memorize correctly. Okay? Questions about this example? It's pretty straightforward. If you weren't here Friday when we introduced the t interval, make sure you go back and watch those videos because it's real important that you remember this. T goes with means. Z goes with proportions. Now, let's flip to the back. The top here is just a Cliff Notes version of the state plan to conclude process that you need to know. It's not going to tell you in state, you write these. It's not even going to tell you state plan to conclude. You have to know this. This is why the practice is important that you do it. Parameter, confidence level, obviously in context. The plan, the name of the process is one sample t interval. If you forget the for mu part, it's not a deal breaker. It's fine. Okay? You're just identifying it's a t interval as opposed to a z interval. Conditions, there's the random, there's the normal. I don't know why these notes are missing the 10% condition because it should still have it in there. So I don't know. The independence condition has to be checked here. All right. I don't know how that got missed. The do step is where you show your work. This is the way it's going to show up on your formula chart. If I can find it on my iPad, I'll pull it up here in a second. It's not going to give it to you in this state. It's going to give it to you in words because we may be doing it for proportions and the values are different, right? So you just get comfortable with it, and I'll show you how it connects on your chart in a moment. Then it says, there's our conclude statement. We're whatever % confident, ... Okay? Now, let's look at this. The first thing on here is not actually a state plan to conclude. This is a sample size question. Before we did sample size with proportions. Now we're going to do it with means. But something has to change, so let's see what happens. It says the city council members want to estimate how many pounds of trash households in their community produce per week. To determine an estimate for the standard deviation of weight of the trash produced a small random sample of households was selected and their trash was weighed. This produced an estimate standard deviation of 36 pounds. Well, why do I care? Well, you got to have that to do sample size. Okay, remember when we did this before? We said margin of error was equal to all the stuff behind the plus or minus, right? T star S of x over the square root of n. Now, there's a problem with this. Did they give us T star? They say it's 95%. Can we find T star?
Yeah.
Remember what the calculator asks us for? It asks us for the area and the tails. Okay, we can do that. But it also asks us for degrees of freedom, doesn't it? T star is dependent on our sample size, isn't it? So the problem is, if I don't know n, I can't do this. Does that make a little sense? So what do we have to do? We have to have a backup plan. So what our backup plan says, we can't use that, we can't use that. So what we do is we use z star. But in order to use z star, you have to use sigma. They have to give you the standard deviation of the population, and then this is still square root of n. All right? That's why in this question it tells you that the standard deviation is 36 pounds. And the z-stars are the same z-stars we used when we did proportions. Anybody remember what the z-star is for a 95% interval?
1.86.
Oh, you're so close.
1.96.
1.96. There you go, 1.96. You got it. Now, let's do a little algebra. We know we want it at most 3 pounds. Greater than or equal to 3 pounds. So I do 1.96 times 36 over the square root of n. So, algebraically, I'm going to divide by 1.96. See where that gets me. Remember, keep all your decimals in line in your calculator. Just truncate it for your paper. Next thing I would do is to multiply by the square root of n on both sides. Get rid of it. That leaves me at 1.53 square roots of n. Then I can divide by 1.53. That tells me that the square root of n is 23.52, and then obviously I need to square it, right? Obviously. So that gives me a 553.19. Is that my answer? Remember, we have to round up, okay? Because obviously 553 by itself is not quite enough. So it's better to have more than you need than a less. So we always round our sample size to a whole number, and we always round it up. So 554 samples is what we would have to have. Make sense? Mm-hmm. All right, show your work. So if you mess up on the end, we can maybe help get you some partial credit. All right. Questions so far? So after solving this, they saw that they had to sample 554 people's trash. Go out and weigh that. That's a lot of work, isn't it? They decided it's too much work. They give up on the hopes of estimating the true mean weight within 3 pounds, and they selected a random sample of 15 houses and weighed the trash for each of these households on garbage day. Here's the results. All right? Here's the weight of the trash. Calculate and interpret a 95% confidence interval for the true mean weight of trash for all the households in this community. This is the way the question will read, but the expectation is when you answer it is that you're going to have that state plan do conclude process spelled out. It's not going to say use the 4-step process. Okay? You just have to get used to it. This is the way the prompt will read, and you walk through that 4-step thing. All right? So you can do some abbreviating. So the first thing we want to do is state. What is it we're trying to do here? We want to find mu, the true mean weight of trash for all households in the community with, what, 95% confidence? And again, don't rack your brain trying to figure it all out because they usually give it to you right in the prompt, what the parameter is, okay? All right, then we do the plan step. First thing we have to do is identify the test. And right now, it's just the one sample t interval. And then we got to run through our conditions. Was this a random sample?
Yes.
Yep, it's stated, but our sample was only 15. And then let's check our 10% condition. Is 15 less than or equal to 10% of all the households?
Yes.
That's a safe assumption. And then normal. Okay, remember there's 3 ways we can figure out it's normal. If the population's normal, well, they didn't tell us. We don't know. Number 2, can we use our good old central limit theorem?
No.
Nope, it's too small. So we have to do what?
Gradual.
We have to do the dang dot plot thing. I know. You won't have many of these because they are time consuming and it's a time test, okay? However, they will usually, in the event that something like this shows up on the test, it'll provide you the dot plot. Okay? But today it doesn't. So let's do this. All right, so my smallest weight of the trash was 19.8. My highest, 119. Okay, so I'm going to do 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 120. Okay. And this would be pounds of trash. We label our axis. And then we just slap the dots on there, okay? Yes, I know it's tedious, but I'm doing it with you, so you'll be fine. 114. $18, 26. Okay, so it's a very boring dot plot. Very flat, very boring. Not much to see there. Okay? So you can't stop with just the dot plot. You've got to give a summary statement on what is it you're looking for and does it pass the test. Okay? So I'm looking at this. I'm looking for outliers. Do I see any outliers? No. Strong skewness? We don't have enough data to show that, do we? So we would say this. You would say the sample data shows no outliers or strong skewness. So it's safe, safe to proceed with the test. Now, everybody ask here, what if it's not, right? What if it is outliers? What if it is strong skewness? Well, never seen one that is in all my days, but if you feel strongly that it is strong skewness, state that, okay? The only thing that changes is that the result, the confidence interval that you create, is not going to be 95% confident. It might only be 90% confident. We don't really know, okay? But you can proceed. You just kind of put like a big warning on it. It's like the results are not going to be as accurate as we wanted. That's all, all right? So don't just stop and forget the rest of this. All right, so that's the state and the plan. Let's do the do step. Now, remember, we need X bar, we need T star, and we need S. Do we have those values? Did they give us the average of these 15? Nope. Did they give us the standard deviation? No. That's so not helpful, is it? No. But we have a calculator to do it for us. So in the spirit of time's sake, we're going to, what you would do, I've already done it. So put these in list 1. Once you put them in your list 1, remember how to do list 1? Stat edit, okay. Then you would go out to stat, calc, and one variable statistics. It'll do it for you. You just have to tell it what to do. Okay? So, to save time, I'll just tell you what it is. You can go back and check me in a moment. When I did this, X bar came out to be 68.85 and S came out to be 35.78. And that's what I need to complete my interval. I'm going to need to find T star, but okay. So I 68.85 plus or minus 35.78 divided by the square root of 15. Now, T star. You don't have to draw the picture at all, okay? But you do have to calculate it. So our degrees of freedom would be 14. That gives me a T star of 2.14. Something like that. All right? Now, you don't need to write the symbol version of the formula, but you do need to write the one with the numbers. Especially if you're insecure about your symbols. If you mess up a symbol, they'll count it wrong. So you don't have to have that, but I would require this so that if something goes wrong in your calculating in the calculator, I can know you set it up correctly. Okay, so let's crank this out. So I get 49.082. 88.62. Okay? There's the do step. So what am I learning? I'm learning I need to conserve my space a little better, don't I? And the conclude. All right, let's make sense of these numbers. Got to have conclusion and context for it to make sense, right? So we are 95% confident. Okay, the interval from
49.08 to 88.62.
62 pounds.
I don't know the next like 30 words.
Captures the true mean weight
of trash produced within a random sample of 15 households.
Don't mention the sample. Don't mention sample. Sample will make your answer wrong. True mean weight of trash in this community.
In this community.
All right. Yeah, you want to make sure you don't mention the sample in the conclude, and you don't mention the sample when you define the parameter. Because we're saying we want to make a generalization about the whole population, right? If you say sample, then it's only a sample. So that's why we bring it back to the big population. All righty?